Okay, so the smallest integer greater than square root of 58. There are two ways you could, well, there are probably other ways you could look at it, but two probably main ways you could kind of think through this. You could just do this really quickly, find out what is the square root of 58. And if I plug that into my calculator, the square root of 58 is 7.616. All right, what's the smallest integer greater than 7.616? 8. So an integer is a whole number. It can be positive or negative, but it's really a straightforward question. The other way you could think about it, this isn't something that you would like write out work for, but maybe in your head, you know that 7 squared is 49, which means that 7 is the same as the square root of 49. And 8 squared is 64. Therefore, 8 is the same as the square root of 64. Again, this isn't work you would actually write out, but maybe this is a process that's going on in your head. And so you can say to yourself, well, I know that 58 is going to be between 7, the square root of 58 is going to be between 7 and 8, because that's where 58 fits in. And at that point, then it's just straightforward. Oh, well, 8 would be the bigger number. So that's the smallest integer greater than 58. And maybe what throws people off is the smallest integer, but it's the smallest integer that's still greater than square root of 58. All right, but that's enough on that question. It's a pretty straightforward one once you kind of understand what they're asking, and most of you were able to get that one right. All right, so we are going to learn about the area and circumference of circles today, and I want to just point out that tomorrow we're going to get some kind of review of all the area formulas that we learned. I'll have a formula sheet available for you at that time. And the thing is, we're going to be moving into volume after that, and we're going to continue to need to use these area formulas. So I want to make sure it's really clear. It's not just like, I'm going to learn these area formulas, that's for area, and then I'm going to learn some new volume formulas. You will have some new formulas, but it's going to still come back to knowing the area. So with that, make sure you're getting some good practice and really understanding how to work with these formulas. None of them are super complicated. We're skipping over some of the more difficult formulas, but that doesn't mean it's going to be easy, because there can be situations where you have to use trigonometry and other things. Luckily today, our lesson doesn't require us to use anything like trigonometry, special right triangles, Pythagorean theorem like the previous days have. We're going to be looking at the area and circumference of circles. Now, the circumference, of course, is just a circle-specific word for perimeter. So it's no different than perimeter. It's just we have a different name for it, for that, because it's a circle. Okay. So on this page, this is, you might want to take the time to write these formulas down. But I do have down at the bottom our formulas. We've got the circumference, that's what the C stands for, is equal to 2 pi r. The area is equal to pi r squared. This is definitely not the first time you've seen these formulas, but you've got it again, and you certainly don't have to have them memorized. Up at the top, I had a diagram. First of all, it shows the circumference of our circle. So you can see that right there. And then it shows the radius and the diameter. Now, one thing that you would have learned in the past about diameter is that since the radius goes from the center of the circle to the edge, and the diameter cuts entirely across the circle, the diameter is equal to 2 times the radius. And that's going to be an important thing. Maybe that could be something else that we write down. Diameter equals 2 times the radius. And that can lead us to another formula. And this is one you've probably learned in the past. It's a different way of thinking about the circumference. So if I bring the circumference over here to work with it for a second, just copy that formula. I'll rearrange it also. I'm going to change it to 2 times r times pi, and I'm going to put a parenthesis around this. So if 2 times the radius is part of this formula, well, look at this. I can substitute the diameter in. So 2 times the radius is just the diameter, therefore diameter times pi. So there's another circumference formula that you might see, especially if you go and do some looking around online, but I'll go ahead and make sure you have it. Circumference is pi times diameter. In fact, pi itself is defined by this relationship. So the where pi came from originally was that people in long ago people, let's just say the ancient Greeks, were looking, and I don't even know if it went back before the Greeks. They were looking at the relationship between the diameter of a circle and its circumference. And they found that no matter how big the circle got, that if you took the circumference and divided it by the diameter, you get pi. So that's where that ratio came from originally. And it's kind of interesting. This is maybe a little bit math nerdy to talk about, but pi is called an irrational number. It cannot be written as a ratio, while at the same time, this is funny to me, it's defined by a ratio, and yet it's still considered irrational. All right, so it's a weird thing, but there we go. Okay, so the upshot of all this is that we have a few formulas to remember. I can get rid of everything here, except I want to remind you that these formulas, and it's one of those things, kind of like yesterday when we were looking at the triangle formulas. It's your choice which one you prefer. So when we were looking at the area of a triangle, you could have done base times height divided by 2. You could have done 1/2 times base times height. Most people prefer this way. And knowing that, I might just stick with using that formula, even though for whatever reason in my head, I think of it the other way. But anyways, your choice on which one you prefer, same thing kind of with your circumference formulas. Those mean the same thing. But, if you like working with diameter more, maybe it kind of depends on which one you're given. So what we're going to do is I didn't want to do that. All right. Sorry, there we go. So that's the other formula. Diameter equals 2 times radius. What I'm going to do is I'm going to give you guys a value, and then I want you guys to be able to go through and find the other values associated with it. And here's the thing. If I tell you the circumference of a circle, I'll just say it's x, you should be able to find from the circumference the radius, the diameter, and the area. All right. If I give you any of these, so I'll even go to this one. If I give you I cannot do things right today. If I give you the area, you can figure out the circumference, diameter, and radius from that. Now, your homework tonight is going to make it a little bit easier for you. And your homework basically just says, if I give you the radius, I want you to figure out the diameter, the circumference, and the area. And that's what we're going to do right now. But I will give you a little bit of practice with the other ones. So with this, let me go ahead and give you one. The radius is 6.5 inches. And I'll just go ahead and fill that in for you, 6.5 inches. So from there, and maybe I'll just run through the first one just to make sure there's no confusion. We want to solve for the diameter. Luckily, we know that the diameter is equal to 2 times the radius. So 2 times the radius is 6.5 right here. And stop me if you're getting lost or confused and you're not sure where numbers are coming from. But this one is pretty straightforward. 2 times 6.5, you can plug that in your calculator, you'll get 13. So it's going to be 13, and because diameter is still just a linear measure across, it's going to be 13 inches. Now I can find the circumference. And since I know the radius and the diameter, it's my choice. Do I want to do circumference equals 2 times pi times 6.5? That'd be 2 times pi times the radius. Or do I want to do pi times the diameter, which is 13? Exactly the same thing, and you can see that right there. So regardless of which one you choose to calculate based off of, you're going to get, and I'm just plugging 13 times pi, and maybe I should point out real quick, you have a pi button on your calculator, which is right here. So you don't need to type in 3.14 or, if you know a lot of digits, you don't need to worry about that. Just hit pi and it gives you lots of digits. So 13 times pi gives us 40.8, and we will keep it rounded off to the nearest tenth for all of this, just to make it consistent. Okay, and now I can find the area. Now we need to use our area formula. I'll create some space at the bottom real quick. My area formula is pi times the radius squared. And since my radius was already given, 6.5, I'll just plug that in. And you might want to do this in 2 steps. You can just plug it all in your calculator in 1 step. So I'm just hitting pi times 6.5 and then squared. So I'll show you on the screen. Mine just looks like that before I get my answer. Once I do it, you can see the answer shows up right there. So it's not too difficult when you are given this kind of information. 132.7. Now, what's my unit for area? Inches squared. This is the only one because now we're talking about a 2-dimensional measurement of the space in the circle. We're not talking about just a linear measurement. And when I say linear, the circumference is a circle. It's not a line, but we still think of it as like I could take a ruler and I could theoretically like bend the ruler around and find out what that length is. Okay. So are there questions on how we used any of those formulas? I do hope it's all pretty straightforward because this is not the first time you've calculated these values. But let me give you guys another example of this, and I will let you guys find the values. All right, I'll keep those formulas. So let's say in this case, your radius is 21.4 centimeters. All right, so anyone can feel free to start filling in the diameter, circumference, and area with those values once you've calculated them. And make sure you're calculating all of them. You don't need to just calculate one and call it good. So we're going to look at the diameter, and let me go ahead and give you one. Let's say in this case, we're going to go with a big diameter. We're going to go with 242 miles. So we're talking about a big area superimposed on a map. But from there, I want you guys to figure out, and I won't put anything in these over here, but I want you guys to go through and figure out what these different values should be. So 242 was the diameter that was given. So that's good. And from there, the radius has to be half of it, which is exactly what we got there. That's still going to be in miles for the unit. For the circumference, all right, the circumference, we have the radius and the diameter, but we were given the diameter to begin with. So I might just as well do pi times diameter, which is going to be pi times 242. And when we do that, plug it in the calculator, you will get 760.3. All right. And now for the area, it's going to be pi times the radius squared. So in this case, it's going to be pi times, now we have to use 121. We don't have an option of using diameter here. And when we do that, I'm not going to do anything beyond showing this part. That can be plugged into the calculator and you can get your answer, which is indeed that one right there. And it's going to be in miles squared. So 45,996.1 square miles. So we're talking about a pretty big area right here. Okay. So this is fairly straightforward. And actually, if you can do this, you can do the homework, right? That's all this on the homework. But I wanted to give you guys something a little bit more challenging before we're done here. All right, so let me clear some things. Oops, didn't want to erase those. And let me get rid of this. All right, it's going to take a second to erase. All right, so now I'm going to give you guys the circumference of this circle is 421.4 feet. And from there, see if you can figure out the other values. It gets a little more challenging when I give you the circumference of the area, but I think you guys can do it. So the answers are up here on the screen, and I like all those answers, and that's good. So hopefully you took some time, you're able to calculate some of this stuff. The hint I gave you, of course, is that we have a circumference formula. You could have started with the radius. So we know that the circumference is 421.4. Sorry, that's 2 pi r. So that should be 2 pi r. So I could, at this point, solve for the radius. I could solve for the diameter. I'm actually just going to solve for the diameter to begin with. So the easiest thing to do is to divide both sides by diameter. Oops, not diameter. By pi. So those cancel out, and the diameter, when I do 421.4, and I'm just putting this in the calculator, divided by pi, I get 134.1. 134.1. All right. And there it is, 134.1. And we do want to round it to the nearest tenth. Now, for the radius, I know that that's just half the diameter, so I'm going to divide that by 2. Now, when I do this, it still rounds up to 67.1. So the radius is equal to 134.1 divided by 2, which is going to be 67.1 when I round it. So if we know the radius and we know the diameter and we know the circumference, well, the radius is the key thing. Now I can just plug that in. So now I can do the area equals pi times radius squared. So it's going to be pi times 67.1 squared. And that's where we can get our final answer. So I'll just put that in the calculator. I'm giving you guys a chance to do the same thing. And I get 14,000. Okay, 14,144.7. And there's something that just came through in the chat. So if you are using, I can't remember the model, but it's a TI model. Maybe there's even some Casios that do this. That what you need to do is there's a mode button. If it's showing up as 14 pi instead of the decimal answer, there's a mode button. And when you click on it, you go down and you're going to see mode print, or sorry, math print as an option that's selected. And then the other one, I can't remember, it says like floating or something like that. So in the menu options, you need to change it away from math print to whatever the other option is. And then you won't get the pies showing up. Let me know if that's working for you. All right. So we were able to go through and come up with those answers. And now let's look at one more thing where I give you the area. So let's say the area of our circle is, I won't make it a huge number. Not that it makes a big difference if it's a big number or not. Calculator does all the work, but I'm going to go with 34.3. We'll go centimeters squared. So maybe we don't solve for everything, but you know, well, I'll just leave it up there. I take that back. Let's solve for everything. So just to give everyone a hint for this one, since we know the area is 34.3 square centimeters, I can go ahead and use my area formula, which is pi r. There we go. We're getting an answer. 34.3 equals pi r squared. We're going to have to do some work here to get that answer. And it will involve doing some square root and other stuff like that. But see if you guys can come up with the answer. So let's start running through this. And if we know that 34.3 is the area, I can start by solving for the radius. And I have to start by solving for the radius. So I'm going to start by dividing both sides by pi. And then, let's see, 34.3 divided by pi is 10.9, which is equal to the radius squared. And now I need to do the square root of both sides. So the square root of 10.9 is 3.3. So the radius is going to be 3.3 centimeters. And then if we know that's the radius, we can just double this. So the diameter is going to be 2 times 3.3 to get 6.6. All right. And now if we're trying to find the circumference, I'm going to come up to the top left now. Pi times diameter, or 2 pi r, gives me the circumference. Pi times 6.6 gives me 20.7 centimeters. So there it is. Those are the answers we were looking for. This is definitely kind of the most challenging type of problem I could give you, where I give you the area and you have to work backwards. But hopefully you can see what the process was. And if you made a mistake along the way, hopefully you can catch what you did wrong. All right. So with that, your homework is actually the easier stuff, where the radius or the diameter is given and you just need to solve for the circumference or area. You don't have to do any backwards solving. So with that, I will let you guys find your homework in Canvas. It's going to be one that you have to submit through Canvas again. If you have any questions on anything, please feel free to stick around. If you're good to go, have a wonderful day, and I will see you guys tomorrow.